let us have the exponential functions for your indefinite integrals. So for this one, your formula is the integral of e raised to u du. Your e there is your Euler's number, that is a mathematical constant, class. Don't forget that is equal to e raised to u plus c. Okay, so if that is the integral of a constant raised to u, that is equal to a constant raised to u divided by the ln of the constant, that is plus c. Okay, let us evaluate example number 1, that is e raised to negative 7y dy. And since the differential of your um, e raised to negative 7y, that is e raised to negative 7y, still multiply it by negative 7 dy. And since this is negative 7 dy, we have to manipulate it again because it doesn't satisfy this one. It has negative 7, so we have to multiply it and divide it by negative 7. Okay, so manipulating the equation, let us divide it by 1 over 7. The integral of e raised to negative 7y multiplied by negative 7 dy. So this is just simply the answer, that is negative 1 over 7 e raised to negative 7y plus c, or it can be written as negative 1 over 7 e raised to 7y, since if we are getting the reciprocal for this one, the sign will change, and we're gonna put that at the denominator, that will change. Okay, that is 7y, that is plus c. That is a final answer. If this is your answer, it's correct. Also this one, that is correct, it's the same. Okay, next, for number 2, let us evaluate that one. A constant, that is the integral of 7 raised to negative y dy. Okay, from your differential calculus, your derivative of negative y is negative dy, and since your original equation is only dy, let us just manipulate it again since it has a negative. So manipulating the equation, it will give us negative the integral of 7 raised to negative y dy, multiply it by negative dy, since negative times negative, it is positive. It will arrive at the same equation. Okay, so that is equal to negative. Let us have the formula, that is 7 raised to negative y divided by ln of the constant, which is 7, plus c, or that can be written as negative 1 over 7 raised to y, that is the reciprocal, ln of 7 plus c. It's the same. That is our final answer. Okay, next, for this one, let us evaluate this one. ey minus e raised to negative y. Let us expand. Okay, so multiplying that, it will give us ey minus e raised to negative y multiplied by e raised to y minus e raised to negative y. Okay, multiplying this to here, it will give us e raised to 2y, and this one to this, that will give us negative e raised to y minus, that is e multiplied by e raised to negative y. Okay, so for this one, negative multiplied by here, that will become e raised to negative y. It's the same, no, with this one, that is e raised to y, plus this one to this, that is positive e raised to negative 2y. Okay, let us just combine this one, this two, that is equal to e raised to 2y minus 2e raised to y e raised to negative y plus e raised to negative 2y. And class, for this one, y minus y is e raised to 0, so that is equal to e raised to 2y minus 2 e raised to 0 plus e raised to negative 2y. And since class e raised to 0, that is equal to 1, class. Okay, so rewriting that in our equation, that is the integral of e raised to 2y minus 2 plus e raised to negative 2y. Okay, that is in dy. Okay, getting the integral for that, that is e raised to 2y dy minus the integral of 2 dy plus the integral of e raised to negative 2y dy. And since that is raised to 2y and the differential for 2y is 2 dy, let us manipulate this one. So manipulating that, it will give us 1/2 the integral of e raised to 2y multiplied by 2 dy minus, this is just a power rule, no, that is the integral of 2 dy minus, that is negative, so let us divide it by negative 1/2 the integral of e raised to negative 2y dy. Okay, we are now ready for that one. That is the integral of 1/2, that is e raised to 2y minus 2y, that is power rule, minus 1/2 e raised to negative 2y plus c. If this is your answer, it's correct, but it is also equal to um, 2y divided by 2 minus 2y minus 1 over 2 times e raised to already 2y plus c. It's the same. Okay, for example number 4, let us have this one. That is the integral of e alpha d alpha divided by 7 e alpha plus 1 raised to 4 thirds. Okay, for your differential calculus, the derivative of the denominator class is this one. No, so this one doesn't satisfy the numerator, so we have to multiply it by 7 and divide it by 7 again. Okay, manipulating again that one, it will give us, let's just erase this one up, ha. Okay, so that is the integral of 7e alpha plus 1, so that is already negative 4 thirds. Let us just bring up that one, that is e alpha d alpha. Okay, manipulating the equation, it will give us 1 over 7, the integral of 7e raised to alpha plus 1 raised to negative 4 thirds 7 multiplied by e alpha d alpha. Okay, we are now ready to get the integral for that using power rule again. That is already 1 over 7 multiplied by 7e alpha plus 1 raised to negative 4 thirds plus 1 divided by negative 4 thirds plus 1. That is plus c. Okay, for this one class, that is already equal to negative 1 thirds. Also this one, that is already negative 1 third. Okay, so simplifying that further, it will give us equal to, let us just get the reciprocal for this one. That should be negative already. That is 3 over 7 times 7e alpha plus 1 raised to negative 1 thirds plus c, or it can be written as equal also to negative 3 divided by 7, that is 7e alpha plus 1 raised to 1 thirds is the same. That is plus c. That is our final answer. Moving on to our example number 5, let us evaluate this one. E raised to 2 alpha d alpha divided by 1 plus 7e raised to 2 alpha. Since the derivative of the denominator is equal to 7e 2 alpha times 2d alpha, that is already 7 times 2, that is 14e raised to 2 alpha d alpha. So that is already, we have to manipulate it again. Okay, so manipulating the equation, since the denominator, no, the denominator, the differential for that is the numerator, let us use again your logarithmic. Okay, so that is manipulating that, that is 1 over 14, the integral of 14 e raised to 2 theta divided by, that is alpha, sorry, that is divided by 1 plus 7e to alpha. Okay, so that is equal to 1 over 14, the ln of the denominator, 1 plus 7 e raised to 2 alpha, that is plus c. Since class, no, that is the the differential of the denominator is already the numerator, let us just get the ln, that is your logarithmic for indefinite integrals. Okay, next moving on to example number 6, let us have this one, the integral of 7 minus 7e raised to tan x multiplied by secant squared. Let us just distribute secant squared, that will become the integral of 7 secant squared x dx minus the integral of 7e raised to tan x secant squared x dx. From your differential equation class, your um, derivative of tangent x is already equal to this one. So this one, it's satisfied already, okay? So let us just get this one, that is equal to also 7. And then the integral for secant squared x. Secant squared x is tangent already. That is tangent x minus 7e raised to tangent x again plus c. So that is just the answer. Okay, let us have your example number 7. So for this one, evaluate the integral of ln e raised to 7x dx. For this one class, if we recall your algebra, your ln a raised to b, that is also equal to b ln a. So let us do this. Let us rewrite this one, that is the integral of 7x ln of e dx class. Your ln of e there is equal to 1 also. So that is written as the integral of 7x dx. Let us just use the power rule for that. So the integral of 7x there is 7x squared over 2 plus c. So that is our final answer. For number 8, so that is the final example for your exponential. That is hyperbolic sine. Okay, your hyperbolic sine 2x dx, that is it. Okay, this is the identity for hyperbolic sine. So if your sine h 2x, that is, since that is x and this is raised to x, for this one also, that is e raised to just 2x, since that is 2x minus e raised to negative x divided by 2. So that is supposed to be raised to negative 2x. Okay, so rewriting this one, it will give us the integral of e raised to 2x minus e raised to negative 2x divided by 2. Okay, that is dx. Okay, is equal to the integral of, let us distribute dx and 2 there, that is e raised to 2x dx over 2 minus the integral of e raised to negative 2x divided by 2 dx. Okay, so rewriting this one, let us just bring out the constant, which is 1/2. That is 1/2 the integral of e raised to 2x dx minus 1/2 again, that is the integral of e raised to negative 2x dx. We have to manipulate this again because it is raised to 2. Okay, so for this one, manipulating that will give us 1 times 2 times 1/2. Okay, that is the integral of e raised to 2x, that is already 2 dx. Since we have divided by 2, we multiply it by 2. Okay, that is minus 1/2. Since that is negative 2, that is already negative 1/2 times e raised to negative 2 x. Okay, sorry, that should be negative 2 dx. Okay, so getting the integral for that, it will give us 1 over 4 e raised to 2x. That is just simply that, minus that is already plus over 4 e raised to 2 negative 2x plus c, or that is equal to, class, that is 1/2 multiplied by, let us just bring out that one, that is 1/2 e raised to 2x plus 1/2 e raised to negative 2x, that is plus c, and that is equal also to 1/2 times, that is, they have the same denominator, so let us just get that one, e raised to 2x plus e raised to negative 2x plus c. And this one, class, it is a hyperbolic cosine already. So that is hyperbolic cosine of 2x. So that is your final answer. That is cosine 2, that is h, x divided by 2 plus c. So that is our final answer for that.